Hi, in the last session, we talked about virtualization and we learned how virtualization and cloud native technologies can help to evolve 5G requirements. Now, we also have some basic understanding of 5G core network. So, let's understand their specific core functions. Earlier, we discussed the basic visualization of the 5G network and we seen its key component. You can also see those key components here. This screenshot highlights the core functions, which is essential to the 5G network operations. Now we have added little more functions in that core network architecture. So you can see some of the newly introduced functions include NEF or Network Exposure Function, NRF or Network Repository Function, and AF or Application Functions. Each of these functions are capable of adding new capabilities to the network. First, we will explore how these functions are typically visualized in the network architecture, and then we will take a look at the description of these functions. The 5G network can be visualized in two main styles. The first style is reference point representation. In this reference point representation, the interfaces between different network functions is specified as point to point connection. You can see that each point to point link is defined by the interface name like N7, N8, etc. This is the similar approach like previous generation technology designs like 4G and 3G. So it can easy to relate if you have experience with the previous generation technologies. The second style is called service-based representation. In service-based representation, the core network functions are shown as services, and these functions are interconnected with the labels, which are indicating the service interfaces of each function. This approach aligns better with the service-based architecture of 5G. In this model, any network function can expose its services to the other authorized functions, so they have better flexibility and interoperability. This service based representation is particularly relevant for 5G as it aligns with the network service based architecture, which is the main reason for its flexibility and scalability. Now, let's explore the main role and functions of these various components within the 5G core network. We will start with the NRF or Network Repository Function. The 5G core network is composed of various network functions. Each one is designed as a service to ensure the flexibility and scalability. The NRF serves as a central repository that stores the profile of all network functions available in the core network. These profiles contains crucial details such as the type of network function, network address, capacity, and supported services, etc. When a service consumer need to locate a service provider, then it communicates with the NRF to find the necessary address and details. For example, if the AMF want to locate SMF, then it will check with the NRF to retrieve the SMF address and availability. The NRF can also provide information that how many instances of SMF are currently running. Additionally, it can provide details about the SMF capacity and other relevant metrics. And with all this information, service consumer can discover and select the most suitable service provider without needing any pre-configuration. Next, let's discuss the AMF or authentication and mobility function. The AMF is responsible for establishing and maintaining the encrypted signaling connections with the user equipment or UE. This functionality enables the UE to register with the network, authentication, and seamless mobility between different radio cells. The AMF also handles session management signaling between devices and SMF to experience a smooth communication between the network. The AMF communicates with the G-Node B through the N2 interface and with the UEs via the N1 interface. Interaction with the other network functions are carried out through the service-based interfaces from the concept of service-based architecture in 5G. Now let's understand SMF or session management function. The SMF is responsible for setting up the connection between the UE and data network. The SMF is a control function that manages user sessions, including their establishment, modification, and termination. And it also handles allocation of IP addresses for IPPDU sessions. The SMF also select and control different network functions over the N4 interface to ensure seamless session management. Additionally, the SMF interacts with the PCF to retrieve policies and configure the UPF accordingly. The SMF is responsible to collect the charging data and it manages the charging functions within the UPF. Next is AUSF or Authentication Server Function. AUSF presents the subscriber home network and handles authentication. It manages authentication by processing the information in the home network and from the received UE data. It retrieves necessary data from the UDM. Next, let's discuss the Policy Control Function or PCF. The PCF is responsible for enforcing policies across various aspects of the network. It provides session management related policies to SMF, like quality of service or QoS requirements. The PCF also collaborates with the SMF to enforce access and mobility related policies, including radio frequency selections, service area restrictions, etc. The PCF interacts with the UE through the AMF to manage the policies, like how the UE should interact with the non 3GPP network, like Wi Fi, etc., and handle network size selection. Finally, let's take a look at the UDR or User Data Repository and UDM or User Data Management. The UDR stores the subscription data and network related information, while the UDM manages this data to support various network functions. The UDR acts as a database and stores the subscription data and the network configuration information. The UDM serves as a front end interface and responsible for accessing and managing the subscription data which is stored in the UDR. The UDM uses the subscription data that is stored in the UDR to perform different tasks like generating authentication credentials and managing UE registrations with the network, etc. So in summary, we have learned about two different ways of representing 5G core network and the role of different core network functions to maintain and optimize network operations. Okay, so that's it for today. I hope this short learning series helps you in developing the basic foundation of 5G architecture and core network functions. In the next learning series, we will understand more 5G concept in more details and we will discuss use cases of 5G and new advancements in the technology. So stay tuned for the updates. If this learning series is informative and helpful, then please like the videos, comment on videos, and don't forget to share. If you did not subscribe till now, then please do subscribe to Learn and Grow community for regular updates. Thank you for watching.